All right, welcome back, everybody. Thank you so much. We're so excited to have you here. This is going to be our last session of the day. It's going to be a fireside chat panel moderated by EPRI's Heather Feldman. Heather, over to you.
Thanks so much, Hannah. This is our closing panel. It's titled Looking Over the Horizon. I'm going to start this session with a number, and I'm going to end this session with a number. So to start, the number I'm going to throw out there is 3. And I'm going to focus on the United States in my remark here, but this is generally applicable around the world. In the United States, we need to triple the rate of carbon reduction to achieve the 2030 Biden administration pledge. This pledge is to reduce the US economy-wide carbon emissions to around 50% below the 2005 numbers by 2030. Between 2005 and 2020, economy-wide carbon emissions declined by 14%. We now need to triple that rate. So this tells us what we need to do, and it tells us by when we need to do it. But how do we get there? One of the critical tools that EPRI believes is going to be essential to tripling the rate of economy-wide carbon reduction is artificial intelligence, which is why we're all here. Our future energy system will go through a digital transformation, and AI is going to be integrated into that. The future energy system must be resilient, reliable, affordable, and equitable. The future energy system will be more distributed. There's going to be more generating sources on the grid, and more of those are going to be variable generating sources. And all of that is going to be really data rich. This week, we heard from leaders in AI and leaders in the electric power industry. Artificial intelligence, to some degree, is a solution waiting for a challenge. And that's exactly why we put together a reverse pitch to talk about the challenges. We heard from the reverse pitch responses yesterday. There's a range of solution options. One size did not fit all. This week's reverse pitch brought challenges to the AI solutions. And here's a few themes that I picked up on listening to all of the talks. The first one is around our views on artificial intelligence. AI provides disruptive thinking. In other words, artificial intelligence is like a new team member. Neil Wilmshurst mentioned this in his keynote. He called it a digital assistant. Others noted that AI provides unconventional ways of thinking about problems. So I'm thinking about AI as a new member of the team that's going to disrupt my thinking. We also heard that AI is vision. AI can help grid operators see. It enables operators really to see these complex options and arrangements of the grid that we can't think about because it's so big. We've also heard that AI is like a check engine light. It can give a warning that something might be happening with an asset. So we picked up on some views on AI. I also heard a theme around data. We have a legacy data challenge. We have a current data opportunity. For the first century that some of our utility organizations have been operating, data was not treated like information. But now it is. So we have to get that legacy data into today's format, and we have to take the data we're collecting it today and treat it like information. We also heard at one utility there are 10 billion data points collected every day. That is a large amount of data. We also know that we have a sparse data set in that we're looking for rare events and the ability to predict those rare events. And we also know that we need to get more data. And one way to do that is by sharing data. The other observation that I made this week is around AI adoption. It was very subtle and in the background of the conversations that we had this week. How are we getting ready for AI? Some utilities are already adopting AI and seeing results. Some are just starting to explore. What we need are more early wins, success stories, more conversations among these two industries to really further the understanding of the technology, gain confidence in the technology, and begin to trust it. Going back to what I said earlier, being a trusted member of the team. We also need to identify grand challenges and use those grand challenges as our burning platform to move us along the maturity scale of artificial intelligence. We have a call to action, but what is it? And that's what I want to dig into today as we have our fireside chat. So I'm going to introduce my colleagues, and we're going to focus on AI adoption. We're going to focus on grand challenges, and we're going to focus on our call to action. So we have with us today Mike SEGALA. He is a PhD physicist and CEO of SFL Scientific, which is a US-based data science consulting firm specializing in developing production-grade machine learning and artificial intelligence solutions across industries. Michael leads SFL Scientific in its mission of delivering state-of-the-art algorithms to enhance research capabilities and drive operational excellence for their clients. We also have with us KOROUSH SHIRVAN. He is the John Clark Hadwick Career Development Professor in Nuclear Science and Engineering Department at MIT. His current research includes the development of physics-informed machine learning and artificial intelligence frameworks and their application to support existing nuclear power plants in collaboration with industry. We have Craig Primer. He is currently directing the plant modernization research teams in digital and information modernization at the Idaho National Lab. Craig's experience in the nuclear industry is over 30 years, and he worked as a senior reactor operator at the Comanche Peak nuclear plant. Liang Ming is a managing director of the Bits and Watts Institute at Stanford University. Bits and Watts is a Stanford initiative bringing together multidisciplinary research teams to enable digital transformation for the 21st century electric grid. And we also have with us Jeremy Renshaw, who's the Senior Program Manager of EPRI's Artificial Intelligence Initiative. And EPRI's AI initiative aims to create an electric power AI community, create solutions, and deliver results. So to start, we're going to focus on AI adoption. And Mike, I'm going to start with you. So what is your view of the level of adoption of AI in the electric power industry? And what are some steps that we can take to accelerate the deployment of AI?
Excellent. Thank you. And it's a wonderful setup. So to level set, I honestly think that nearly every industry is way behind in their overall adoption of AI, right? And by adoption, I don't mean just running a single one-off POC or having a small kind of internal R&D team. By adoption, what I'm talking about is really having a systematic strategy of high-value use cases, mapped to data, mapped to technology, mapped to teams that are all put in place to actually productionize these workloads, and most importantly, actually capture ROI against that investment. So unfortunately, we're led to think very differently. We actually think everybody's doing this, right? Because we see folks like Amazon and Google and Tesla, right? Amazing technology, self-driving cars, Alexa, all these things. And our assumption is, well, if they're doing it and everybody else is talking about it, it must be true across the industries. But that's not true, right? It's really just good marketing. So the issue is when we're adopting any new technology, there's always going to be a very high barrier of entry to building and integrating these tools. It's whether you're buying something off the shelf, right? Somebody built a really cool AI product, I'm just going to integrate that. Or if you're actually doing something bespoke, right? And in the power and utilities industry, this is made even significantly more difficult based on the regulations that are set and imposed on you guys and the consequences of getting things wrong, right? In most industries, hey, the advertisement was served to the wrong person. Nobody really cares. For you guys, the implications are significantly different. So, the question that you pose on what are the steps or what do we have to do to actually overcome some of these things? The first and foremost is way before deployment, we must set a very clear strategy and mandate by the business executives, right? The folks at the top on what AI-centric use cases will really move the needle for that organization. And then once the business buys into that, they say, well, I need to invest in the technology stack, the data, and the personnel to go and actually attack these problems. And these problems are fundamentally different than traditional software, right? So you have to think completely different about the problem space. And then just to kind of finish the question here, right, on the other end of that, from the strategy side, to really actually accelerate deployment, you need to accelerate the actual education, like what we're doing here today, of how these technologies will influence the stakeholders, right? So AI systems are non-deterministic. That's the issue. And they introduce a significant amount of risk. And that risk goes to the business, it goes to the technicians, it goes to the IT. And none of these people signed up for your fancy new AI, right? So you need to get them on board and understanding how to adopt it and what it means to them and the implications. Otherwise, you're basically just making a software version of a paperweight. So long-winded, but in summary, right? AI is hard. It's not trivial. It's not easy. Let's not pretend that it is. But you most likely probably at this point don't have all the internal resources to solve all the problems from adoption to strategy to deployment, which just means there's a great ecosystem like the folks here that will help you in this journey and be a part of that adoption with you guys so you don't fail and those risks are reduced. So I hope that answers some of the questions.
That's great. And I've got some things that I want to explore further with you here, but I want to hear from the panel first before I go back to you, Mike. So, KOROUSH, what are your thoughts on adoption of AI in the electric power industry, and what are some steps we can take?
Yeah, thanks, Heather, and thanks for having me here. I can mainly speak on the generation side. As I understand it, even from 1980s, by definition, there were adoption of AI systems, plants having generators coupled to a plant via phone lines and having expert systems that actually interpreted the generated data and gives you maintenance needs. But at the same time, if you look at, advanced level of adoption of AI, you can just look at a combined cycle natural gas plant and compare to a nuclear plant, and you really see a, order of magnitude in terms of staffing, which really has a lot to do with automation and digitalization. And so then you ask, why is that? On the nuclear side, there's been a lot of regulatory creep that definitely makes things slower, makes the digital technology more expensive. I won't expand on that. My colleague, I think, Craig Premier is an expert in that area. And to your second question on how can we accelerate deployment of AI, I completely agree with what Michael mentioned. It's really comes back to investment, multi-year partnership, and it really requires both culture change as well as the way the utilities do business. And the utilities, it involves a lot of complicated regulations on the commodity they sell, and it's really not straightforward to have themselves have dedicated individuals to work on AI initiatives, and that's really I think the key for its acceleration.
All right, thank you, KOROUSH. You mentioned Craig, and he's got some expertise here in looking at modernization and sort of some of those compliance aspects and how to automate those. So, Craig, what are your thoughts here?
Well, and again, appreciate the opportunity to discuss this with you and everyone else joining. I truly believe that we've hit on a couple of the key points. Trustworthiness of AI is a huge issue for adoptability. So dealing with that transparency and being able to thoroughly validate the different applications that are being considered is a huge piece of that. And that enables not only the end users, but also the regulators to determine the effectiveness and making sure that as they try to improve efficiency, they don't erode safety or reliability. So that's a really important piece to that, is how you manage that. The other thing, and I think a bit about what KOROUSH just said about complexity and what Michael said about mapping data. There's just such a huge effort underway to go from what was a paper-based, manual-centric approach and modernize. So we talk about digitalization of hardware, but that's similar to what we need to do now with data. And that is to map out data in a meaningful way, looking at how it'll be used. And Michael made the point of setting a top-down kind of approach on what's important. So mapping the use of data to a business need and then bringing in the right types of technology to automate is a big piece of that. So there's a lot to do there. And I think in the learning loop, there's a language barrier going back to early days when it was people doing everything. Anybody that's been on an international team knows that as you introduce different languages, it creates complications and challenges. So we're adding a new teammate. Heather, you mentioned a new teammate. We've got a new teammate in AI. So how do we overcome those language barriers? You have programmers that are programming in a computer language. You have data scientists and machine learning experts that are introducing algorithms and different things that the end users may not understand or may not be able to completely provide meaningful feedback to. So how do you create a team that can have an effective learning loop? So as we introduce these changes, we can identify issues and get them corrected quickly. So I think those are some of the big challenges. I think as far as where we're at now, we're in that early adoption phase. So lots of people are looking at different challenges and solutions. So creating that community of practice and sharing information is a huge piece of that. So I think that we're aiming in the right direction, and I'm looking forward to see how we move this forward.
All right. Thank you, Craig. That's great. And Ling, I'm going to turn things over to you and hear your thoughts on the adoption of AI, especially as you're thinking about that 21st century electric power grid.
So thank you, Heather. And I also want to echo the previous panelist mentioned. I think we have the same observation. If we really want to use the typical 5-stage technology adoption life cycle, like innovator, early adopter, and early majority, and late majority, and the laggard, I would say in utility sector, we are in the very early stage, either innovator or in the early adopter stage. Okay, and I want to piggyback one of my friend, Daryl Willis of Microsoft, mentioned a couple of months ago when on the panel that has a moderator. 90% in the energy sector, 90% of oil and gas company, they are try an AI different applications. Just give some statistical number here, right? But think about the utilities. We have invest on utility, public utility, and a lot of co-ops, and where we are. And then I like Michael's suggestion in terms of how to accelerate the deployment of AI. So I would say, for the utility category of early adopters, which means that they have tried AI technology for some applications. We heard in the last 3 days in terms of digital twin on the nuclear sector, asset management on the generation, and also transmission, substation, transformer management, etc. Right? I categorize them into the early adopter. And for many of Bits and Watts affiliate members, they presented in the last couple of days, like RTE and PG&E and Turner, etc. And they are also on this category. So the suggestion, I 100% agree with Michael. We need a systematic approach to establish strategies to implement technology and invest, finance and investment plan, and also staffing plan. Okay, and because they will realize that the application not just for one area. Their business are very broad. Some of them own generation on the retailing markets. They don't have any transmission or distribution line. Some of them is very vertical utilities. So they have a centralized vision and a strategy to manage that. And but I also like to highlight another thing, which is we still have a lot of utilities that may not have enough resource to try any AIs. So my suggestion to them is just dedicate some resources to identify some AI use case, low hanging fruit, easy win, and with very clear return on investment, as you heard in the last 3 days, and just conduct some pilot and just try, and you will see the benefit very quickly, especially in asset management. Then on the early adopter, I also want to add three things I learned from some utilities they mentioned. Uh, you establish your strategy, look into three things. One is the data common, all the data issues. I think we're going to discuss more later. Second uh, is the framework common. How to establish an enterprise structure, be able to handle different type of AI application. Last but not least, I don't think it's a big challenge, is a code common. We have a lot of different algorithms, natural language processing, computer vision, and deep learning, reinforcement, you name it. I think there's a lot of open source software available. OpenAI, DeepMind, you can find a lot of code. But these codes are very generic. They're not specifically developed and tailored for power system or electrical grid application, electrical power system application. You know, needed some work to create a code common for the utility applications. So I will stop here. Back to you.
All right, thank you, Liang. And Jeremy, what are your thoughts on this particular topic?
Yeah, so Heather, this is a great question. I would say across the industry, AI adoption is relatively low, but the interest is very high. Case in point, each of our last two meetings earlier this year have had over 500 attendees. So lots of people are interested in growing their AI capabilities across industry. And so one of the key items that we need to overcome is, as Liang mentioned, getting the early adopters into those later stages of adoption. So as we highlight some early wins across utilities with AI vendors, to be able to scale up our AI capabilities across the entire industry. So one of the things we really need to do, and this was talked about in our Monday panel, is have high reliability of these AI algorithms. So be able to have lots of training and test data to be able to vet them and get out some of the potential bugs or get high reliability within the training data sets that we have. And I'll steal a quote from a good colleague or a good friend of mine and colleague, Greg Selby, who mentioned that utilities like to line up to be fourth. And what he means there is no one really wants to stick their neck out and be first or second. But once they do have a technology that's vetted and that's reliable, then they line up to be able to adopt that. And I think we'll have the same thing within the AI community in growing this relationship with electric power, that as we're able to scale up and have these small wins and proof of concepts or POCs, then we can start to scale those up to an enterprise-wide type solution. But as Mike SEGALA mentioned earlier in our meeting, that it's easy to have wins in the proof of concept stage, but it's very different once you get up to an enterprise level deployment of AI. So you need to be able to understand how to scale up from a proof of concept to an enterprise-wide deployment. And we also mentioned this earlier, that we need lots of data. So any specific or individual utility may not have enough data to be able to support this. So data sharing agreements between utilities really globally and not just within any one country or region are going to be necessary to make this happen. So I think that's some of the steps that we need to do to be able to grow our AI adoption across the industry. So Heather, I'll turn it back to you.
Yeah, thanks, Jeremy. I picked up on a few themes here. One of them is around culture change. And let me just go back to Mike real quick, because you said it really succinctly. We have to think differently than we do about traditional software. So can you elaborate on that for just a minute?
Yeah. So traditional software is deterministic by nature. You have a fancy UI, you have some if-then statements, right? Some very cascading logic that you can say, this is the cause, this is the reaction. And this is how most systems are built. That's traditional software systems. AI systems, by definition, are mathematical and they're probabilistic, meaning there's some random generator, there's some random seeds. If you run the experiment once, it's not always going to look the same. If you inject different data, it's going to look differently, right? This non-determined nature is a large challenge and barrier for a lot of people to have to overcome in the adoption of such, right? Take your radiologist, whose their job is to diagnose cancer. That's what they get paid for, and they're the world's best at doing that. Now you're going to say, hey, I built this cool AI tool that can diagnose cancer at 97% accuracy. Build this into your practice. Can you imagine the adoption principle, the change management, the risk that that physician or that NDT engineer or that drone pilot now needs to take and say, well, I don't even understand what this neural net is, let alone why my numbers are changing from a probability score, right? It's a completely different mindset. And it's not just a mindset, it's a technology, it's a mapping of the infrastructure, the entire paradigm. There's really not even a close analogy to traditional software from when an AI software, besides the word software. I don't know if that helps clarify the situation, but it's literally the exact opposite of what people are used to.
In my mind. And when I think about a topic like this, I think about how I would feel if somebody dropped an autonomous vehicle into my driveway and took away my normal car. I would panic a bit. I would not know what to do. I would feel very uncomfortable. I'm not sure I would trust my car initially, but I'd get in there and I'd let it drive me places and I'd slowly but surely figure it out. So that was really, really great insight. And as I opened up the panel, I said Liang, it sounds like you have something to add.
I want to add one thing on this culture change, because utility sector by nature is, by nature of the work, keep the lights on, right? It's a very risk averse industry, and I'm not saying they need to take more risks. That's very important, and to keep the lights on. But we also see the shift, the traditional utility into a, from regulation driven, reliable, low risk environment to the technology driven, face a lot of uncertainties, like distributed energy resources, like for instance, the FERC 2222 in the United States, and also so to European countries, and also very complicated marketplace, especially European countries. It's a very dynamic retailing market, and they need to think about how they need to change the business model to able to ride the new technology, the opportunity give to them, or give to us. I'll stop here.
All right. Sounds good, Liang. Thank you for that. As I wrapped up my opening remarks, I indicated that AI adoption is part of this conversation, but also creating a burning platform, a grand challenge. And I think it was Michael that put it in the context of it needs to be executive driven, it needs to be something impactful. Well, I'd like to take a few minutes and brainstorm with you all on what are some grand challenges? What's your big idea? And what do you see as the biggest barrier to that big idea? So, Craig, let me start with you.
Thank you. There's a couple different areas that I think are of interest for developing some grand challenges around and it breaks down into two areas, really: human in the loop and no human in the loop. So there's two different areas, and I think we got to remember, the narrow AI versus general AI, and there's different applications here. So I think two different ways to look at this. The first one with talking about the team member. So in the nuclear industry after 3 Mile Island, we recognized how the operations team was focused on a problem and missed the bigger picture. And so we introduced some extra watch stations that were called shift technical advisors, and they were to monitor the plant outside of the casualty and just keep awareness. So I would propose a grand challenge of how do we develop that new team member that takes on that type of responsibility, maintaining overall awareness of the plant and making recommendations to the plant staff on what tasks or what actions to take during normal or emergency conditions. So some of the challenges, of course, with that type of approach is data and what would be the information that a normal STA would be looking at during those types of events. And so how do you bring that together? How do you do the analysis that a human does? And basically is using creativity and problem solving to look at disparate types of information and understand it well enough to then bring to the operating crew. So I would say that would be a grand challenge. How would you create that intelligent agent that could assist the utilities in the control room or in engineering or maintenance, whatever it might be, in decision making? And then the second idea is similar to that in the kind of how would you gamify or create some type of expert system that could plan work. So work management tool that could fully go, take on an AlphaGo or a Deep Blue type of approach that takes on an outage, responds to changes in a way that always gets you to the shortest duration, no matter what kind of move chance and chaos throws at you during outages. You would have the best set of actions laid out in front of the outage managers or the senior leadership to advise them into how to take the activities and rearrange things to be successful no matter what happens. So I would say those are the two grand challenges what I think that utilities could think towards and be leveraging AI and really helping out solve some problems.
Work planning and then intelligent agent for awareness of the plant. Those are great ideas. Michael, what are you thinking about in terms of grand challenges?
So my colleagues on this panel are so much more experts in the power and utility space than I am. So they will have all the grand challenges mapped out in the world. And I think they'll probably be able to talk to those a little bit more eloquently than I can. I think I can focus, Heather, on the second part of your question on once you've kind of defined those grand challenges, how do you really start solving them, right? Because that was kind of the second part is what's the barrier to success if we had autonomous agents or if we had, reinforcement learning on the grid and things like that. And there's been a theme already, and I'll just repeat it again. The time spent early on to acquire, annotate, and organize data for projects that will actually generalize to new conditions. So I think we talk a lot about data and data capture, and that's just, let's get some data in and we're going to use that. So that's one step of the equation. The other side of the equation is really, once we've kind of mapped out a system, let's assume we only have the power grid of St. Louis. Well, does that actually map to Boston? And if so, or if not, all the work that you do in this one localized space from an AI point of view may not at all scale to the next space that we look at. So in the hundreds and literally hundreds of AI projects that we've worked on, the common issue is really around having a statistically significant and generalized data set to solve a specific problem. I'm gonna give you a very simple example, but it's one that, we see literally every day. So let's assume that we're a drone pilot and we want to start embedding AI on the drone and we want to do some visual inspection of a crack, right? Very straightforward use case. We're going to say, okay, let's go out and collect a whole bunch of data. So we do that, right? We go out, we fly the drone, we collect some data. But in our experiment, we fly only during the day. It's perfect sunny, no clouds, no storms, no nothing. And we get within 10, 15, 20 feet of that structure to find really beautiful cracks. You give me that data, I will solve that problem all day long with absolutely no effort. Now, the problem is where these things really break down is we say, okay, we've built this POC, we've built this training model, we've shown it to the business, everybody buys in, it's beautiful. Now let's go deploy this in the field. What happens is, well, for whatever reason, you can only get access to fly now at night. And not only at night, you're flying within 100 feet instead of 10 feet. So you've literally changed the entire scope of the problem. It sounds the same on paper, but the dynamics are completely shifted. So your algorithm will fail, the project will fail, just because you haven't captured the essence of the problem. And this plagues pretty much every project that we deal with. So I would say back to, when we're thinking about grand challenges, it's really make the general assumption that your data isn't representative of the real world. It might be representative of your POC, but in the real world environment, assume that it's not and continually try to improve and encapsulate that. Because literally in the hundreds of projects we've been on, 99.9% of them have that issue. So I'm assuming this will scale for most projects moving forward as well. So that's my feedback on the some of the ways to overcome it. And I'll let my colleagues talk about the grand challenges a bit.
I think that's fantastic, Mike. And that paints such a great picture that you can't just start with something small and expect that you can automatically scale it up. And I also, as you were talking, I wondered a little bit about your example of going from taking images in day to taking images at night. If we were to approach a human team, if you will, and said, okay, guys, we're now changing data collection from daytime to nighttime, we would automatically start to plan and sort of regroup and devise a different system for doing that. But I think we have an expectation that AI can take that on itself, and it can't.
Correct. And that's where it comes down to just a misleading interpretation of what these AI systems do. At the end of the day, it's linear algebra. What can linear algebra really solve? It can't solve the grand world challenges, but we think it can because we see really cool commercials on TV. So to your point, Heather, it's about being very methodical and scientific about building the complexity and understanding that roadmap and then layering on the complexity and the new data types and the new situations to build it properly instead of just naively assuming, oh, it's going to work because I see cool commercials. But yes, to your point, exactly.
Yeah, that's great. And I appreciate you talking about sort of the challenge versus the grand challenge. So let me turn things over to KOROUSH. And what are your thoughts on grand challenges?
Yeah. Thanks for the question. I think follow on with Michael just said, moving beyond the linear algebra, as he put it. And perhaps it's because I'm from academia. To me, really building the complete domain knowledge with advances in 3D modeling and physics behind failure modes is really the straight forward way to enable digital twins and really harness the power of AI behind it, because this touches beyond just the physical power plant. It touches the predictability, maintenance, performance, and is critical really for enterprise asset management, which is what the core business of the utilities. I think on the AI side, I think Michael also put it very well with his the cancer analogy. This is something I've also see a lot, because at the high end, the computer science colleagues really continue to treat AI in engineering as a classifier, because frankly, there is no strong theoretical basis for its use for predicting a specific performance, because at the end, again, it's a linear algebra. But as an engineer, I know that there are physical trends in the structure system components that we're trying to utilize AI. And we have to, that kind of, the two communities are out of sync. So the advancement really on focus on classifying versus we really need advancement in, on the engineering side. And then, the last thing, the biggest barrier, I think it really, again, don't want to repeat everything everyone already said about importance of investment, but really the root cause to that, to me, is, utilities cannot do R&D on their recovery when they get, when the technology, new, let's say carbon-free technology or smart grid technology gets a subsidy, the R&D cost under recovery doesn't really go back to utilities, so they're not really in a position to do that investment. So really, that mechanism has to change in order for them to actually be able to do this investment to enable really adoption of AI.
All right. Thank you, KOROUSH. I'm going to turn things over to Jeremy next.
All right, thanks, Heather. So across EPRI, we have about 50 or 60 active AI-related projects. So it's a little bit asking me to choose between my favorite baby or my favorite kid. I've heard two good ideas from others this week in terms of grand challenges, in terms of both the autonomous plant, in terms of how can we get a plant to mostly or fully run autonomously. Second, also the autonomous power grid, where the power grid can run itself. So I won't hit on those anymore, but I'll throw another one out that we've talked about a little bit this week. And it's related to grid integrated buildings. So if we look at buildings in general, they consume about 45% of the total electricity globally. So that's a huge chunk of what we're looking at. And one of the things we've been looking at is that buildings actually waste a lot of the electricity that they use. So we're heating and cooling areas that we don't need to be. We have different lighting that's on when it doesn't need to be, and various other systems that can be used at different times of day or used in different ways to be more efficient and more effective with the resources that we have. In fact, I'm coming to you right now from EPRI's Building 3, where we're running a pilot project using this building that I'm in right now to be able to use AI to automate the operation of the building and operate different systems within the building. And the goal, and what we've seen with some similar pilot projects, is that we can save up to 30% of the energy usage of a building. So if you multiply that out, 30% of almost half of global electricity, that's a huge fraction. We're talking close to 15% of global energy utilization can be reduced right now using existing technology. So we're very excited about this project in addition to the other grand challenges that have been thrown out. So we're, sort of eating our own dog food, so to speak, to test it on our own facilities first as we scale up the adoption to others. So as we talk with different utilities and AI companies, we've had a lot of excitement, a lot of engagement around this topic. So I think this is one where just with existing technologies and demonstrations, we can scale it up rapidly and have a huge global impact. So it's not just about reducing the energy utilization, it's also about shifting when you use energy so that the utilities can get a benefit in terms of reducing the peak load. And as we reduce peak loads, we can also transition more to low and zero carbon generation sources. So while we're talking about close to 15% reduction in overall electricity usage, we can actually reduce the carbon emissions by a fraction that's even greater than that. So we're very excited about where this leads and the fact that there's a win for everyone. So the customers who are using the energy get a lower energy bill. The utilities also are able to shift the usage of their assets and keep the high cost assets offline more often and utilize their lower cost and lower carbon emission sources. So there's really a win for everyone, for the customer, for the utility, and for the environment. So we're really excited about this opportunity. So Heather, I'll turn it back to you.
Yeah, thanks, Jeremy. And I love that you picked an example that is very real. The building that you're sitting in is a grid integrated building using artificial intelligence. That's awesome. Really appreciate that. So I'm going to turn things over to Liang for thoughts on grand challenges next.
Thank you, Heather. And usually what I do is you one get one free, right? So I give you two. One is the first keynote. Neil mentions TMI, right? And his good friend Michael, and the nuclear operator. So the first challenge is really the AI assisted real-time decision making. Use AI. But I'd like to challenge it a little bit more, and would like to echo Cheryl Instead, who is a former DOE AI and Technology office, and she participated in the breakout room yesterday, maybe Tuesday afternoon, and she mentioned one thing which is really interesting. Is in the normal condition, AI can assist in real-time decision making. And how about we are in the natural disaster or the either physical attack or cyber attack? How we can create a real-time decision making with AI in a more fault tolerant way? That's the first grand challenge I'd like to give to you. And the second is as I mentioned, the business model change a utility. Traditionally, utility has very clear responsibility, which is keep the lights on, reliability. And also any company has another responsibility is operational efficiency, right? But as you mentioned first beginning, the decarbonization, that's a new responsibility utility and many sectors are going to take. And also the resilience, as I mentioned, is another responsibility. Last and but not least is the environmental justice and energy equity. That's another responsibility I'd like to highlight. Okay, when you consider all responsibilities, reliability, resilience, decarbonization, energy equities, how do you plan your infrastructure in the future? With consider all the additional responsibility or new responsibility you are going to take. So another challenge, Actually, is we are funded a grand challenge at EPRI, at Stanford as well. Is we call the AI for decarbonized, climate resilient, and energy equity infrastructure and service. Because if you think about data, the data coming from different place. Traditional utility data, environmental justice, a lot of open source, open data from the census data and other sources available there. And climate data, you talk about NASA and talk about NOAA, there's a lot of public available data there. How do you link all this data together, which is a proprietary and a public data, to help you make decisions to harden and plan your infrastructure for the future? So, Heather, hand it back to you.
Those are great examples looking at how can we use AI to become more flaw tolerant, at how we can really use AI to plan infrastructure, but plan infrastructure in a different way than we've done in the past. I think those are really great grand challenges. I'm going to stay with you, Liang, as we pivot towards this call to action. And I'm looking for two really quick answers, so we've got some time for questions from the audience. So what do we need to do tomorrow? And what do we need to do 3 years from now?
Tomorrow, very quickly, dedicate some resource to identify interesting AI use case and you can try, or you can taste the flavor. Right? And 3 years long term is, as I mentioned, industry utility is very low, risk average industry. But you think about the investment of R&D in utility sectors. We need to accelerate innovation and R&D for the utility sector adopting the AI technology. So I give you some numbers, from the book, which I'm reading these days, and this book, and Bill Gates' book, How to Avoid Climate Disaster. And he has a number say that the energy industry investment in R&D is 0.6%. Then the power electronic and health industry is way above 10%, 10 or 13%. It's a magnitude order different. And I read some other data say that energy sector is about 0.1%. Okay, we really need to invest more in the R&D in the energy sector, in the utility sectors. So that's kind of long-term strategy I'd like to give. And then the way of that is really create a consortium between utility and the IT sectors, because they have a lot of experience of adopting the AI, apply AI on different sectors. And they are risk taker, and how the utility can work with them. And because they are also customer of utility customer of them, they should work together and form a consortium, and with government jump in to fill the gap of R&D gap. And really a consortium, university, government agencies, industry, including both utility and IT sector, form a consortium of applying the AI into the energy sector, into the utility sector. That's kind of the pitch I'd like to give as a next step.
All right, very good. Thanks, Liang. We're just going to go around the virtual table here. So Craig, what are we going to do tomorrow? What are we going to do in 3 years?
I think I would answer that this way. I think what we could do tomorrow is embrace that this is coming and set up and just mentally prepare for this transition. It's hugely critical that for certain industries to adopt artificial intelligence and machine learning to drive down costs so they can stay competitive, speaking directly to nuclear industry there, high overhead, and with the manual approach that's utilized right now. So from the leadership down through the organization, adopting and recognizing this change is coming. So setting up the organization around that. So you've probably heard of technology readiness level. There's human readiness level. There's organizational readiness level. You've probably heard of it as maturity models. But we need to think about that, and the organizations need to prepare for that. What can we do over the next 3 years? And I think, again, to the nuclear industry, very risk adverse. So pick some challenges that are outside, the safety concern areas out in your, maybe demon water systems or things that are considered low to no safety risk, and start applying some of these different technologies and get that confidence level up and show successes. You'll start to convert over not only your own organization, but also other regulators and folks that will be very interested to see the types of results that you'll achieve. And so I think that's the near-term, long-term approach I would suggest.
All right. Thank you. Over to you, KOROUSH.
Yeah, I would, to put it shortly, I would say tomorrow you got to get a buy-in that the digital AI asset can be even more important than the physical asset. You got to have that buy-in. And then in 3 years, again, we have to fundamentally change the way the R&D kind of flows towards utilities and vendors and the stakeholders.
All right, very good. Thank you, KOROUSH. Your quick thoughts, Jeremy.
All right, thanks, Heather. So first I want to echo Liang's point in terms of we need to do a better job of collaborating together. And if we hadn't beaten this enough into your heads, that is really the purpose of this meeting, to be able to develop collaborations, get people involved from the AI and electric power industries. So we really need that engagement and involvement. And something else that we can do today is really sharing data so that we're more efficient and effective with the resources that we have. Utilities sit on a mountain of data, but that mountain isn't enough. We need a mountain range of data so that we can have enough to be able to properly train our AI algorithms to be efficient and effective in the future. And so something that we need to do years from now is, as we develop these collaborations, as we bring in this data, we need to execute on these projects and scale up our AI capabilities across the industry. So we can either innovate and disrupt ourselves, or we can be disrupted by others. And the first is highly preferable to the latter. So thank you, Heather. Back to you.
Thanks, Jeremy. I'm going to turn things over to Michael for your thoughts.
Yeah, I mean, I think the panel has said it beautifully. Just my very, very quick take, regardless of the objective the organization has, you need to invest in experienced leaders that understand both sides of the equation, right? The business and the technology side and the implications. This person, whomever they are, needs to vet ideas, vet tools, vet software, and develop that strategy around leveraging data and resources. Again, right, AI is not trivial. It's an extremely hard thing to do post-POC. And having a dedicated leadership council, leadership team, whatever it is necessary for success. And then I'll echo Jeremy's last point. Data sharing is probably going to be the most critical thing to actually long-term success in all industries, especially in this industry. So ways to broker that will absolutely accelerate real adoption and real deployment.
All right, very good. I think this has been a great conversation, and there's some awesome questions over here in the chat as well. I'm gonna dive right in, and we'll see how far we can get with these questions. So we didn't have time. We didn't talk about the workforce and the people aspect in any detail yet. So I'm gonna ask this question that touches on that. So the question is, what's the right balance of staff resource to AI, and at what level of dedication? Is it just good knowledge and being knowledgeable, or do we need to have actual solution developers on staff? So who wants to jump in?
I could take that with a biased opinion. I think it depends on what the organization wants. If the organization wants to rely on other software and other platforms and just integrate that into their system, that's okay. But they still need to know the implications of that system on the rest of their technology in the business. So somebody still needs to be highly knowledgeable of, hey, I put this in and I got a prediction of X. What does that prediction really mean? What are the implications of such? That takes true technology understanding and implications of what those algorithms have done. That's if you're a buyer of other vendors. If you're going to be developing this yourself, you absolutely need dedicated resources that, again, to my last point, have a profound understanding of how to build this technology. Because again, this is not very standard kind of software. What it means from a hardware, a software, a security, a licensing, an infrastructure, this entire worldview. You need experts in that space on the data engineering and the data science side. And then you also need a leadership team who understands what it means to get a probability score. I am 97% accurate on determining cracks. Well, is that meaningful? Is that good for my business? Is it bad for my business? What does that mean? Those implications take understanding and education. So regardless, you do need experts. It just will depend if you're a buy versus build mentality.
All right, that's a great perspective. Leanne, go ahead.
I 100% agree with Michael said, and also I would encourage folks to listen to the keynote speak yesterday from C3 AI regarding generally large investment utility, large utilities, they have a resource, can have dedicated data scientist team. Actually, we do see that from a lot of utilities in the United States, like Pacific Gas Electric is an example. They presented yesterday, a couple of days ago, right? And some relatively small utility and limited resources, then they will take the first approach, basically have an engineer, have some knowledge, but rely on the technology provider, be able to provide the solutions. But one thing I want to put here is more like a long-term workforce need. I want to put it as an educator in how we can attract more students into the power industry. Because the training that they are taking is really different, like 20 years ago, I was trained. I was trained as more like a model-based approach. But these days, the kids, they don't know how to use Fortran. They don't know how to use C++ or C. They know Python very well. And a lot of AI algorithm, and as I mentioned a couple of days ago, Stanford engineering undergrad student, they have taken the machine learning or AI one-on-one class. Okay, I will stop here and back to you, AI.
And Heather, if I could add one more thing on that, just really quickly, there are lots of free training resources available around the world. So we have MIT and Stanford both represented on this panel. Both of those universities are top universities in the world and have free training resources and low-cost training resources that they have made available. Similarly, EPRI has training on AI and data science. So really what we're looking to do here is provide people with resources to be able to understand what's going on. We're not trying to replace the SME. We're trying to give the SME additional knowledge on data science. We're trying to give the data scientists additional information on electric power to bring them closer together so they can talk the same language and be effective as they work together. And you can get links to a lot of those training from our EPRI website at ace.epri.com, just ace.epri.com, and it links to free training from around the world, not only from Harvard, Stanford, MIT, and other top universities, but many other organizations from around the world.
All right. Well, thanks for those comments as well. And a big thank you to each of you for joining me today at this Fireside Chat. I've enjoyed it. I think this was really a lot of fun. And as I kicked off the panel, I started with a number. I started with the number 3. And I referenced that we needed to triple the rate of carbon reduction to achieve the 2030 Biden administration pledge. Now I'm going to end on a number that focuses on the scaling of AI. And we touched on that as we talked through this panel. So the number I'm going to choose here is 80. The digital transformation is here. And leaders in utilities organizations recognize this. 80% of utility executives believe that they risk going out of business in 5 years if they don't scale AI. So scaling of AI is really, really important as we move forward on this journey. So I encourage you to join AI.EPRI, join our conversation, our community that is bringing these two industries together to assure that this statistic doesn't become a reality. I want to personally thank each and every one of you for joining EPRI to accelerate AI innovation for a clean energy future. We look forward to identifying collaboration opportunities to work together with you. And get out your calendars and mark down September 28th through September 30th for our AI Summit. This is where we're going to take what we've learned here in the reverse pitch and work together to take action and make concrete progress on accelerating AI solutions for the electric power industry. So I look forward to seeing you very soon, and I'm going to turn things back over to Hannah.
Great. Thank you so much, Heather. And thank you so much to all of the panelists from today. I think that was a wonderful way to end the week. Very great fireside chat. All right, guys, I just want to reiterate one more thank you to all the speakers and panelists that we've had throughout the week. It's been very productive. I think we've all learned a lot about AI. Like Heather said, save the date for the summit. We will see you back then. We will send out some follow-up messages just so you have access to the recordings. And if you guys have any further questions, don't hesitate to reach out to EPRI. We would love to help you. Thank you so much. Have a great weekend.